Welcome back, students. Here's a video lesson on parallel and perpendicular lines. So we'll start with every time you see parallel lines, if you could immediately put same slope or equal slopes, that would express your knowledge of the content. So that's a good idea to do that right away, as soon as it's in the directions on a problem, especially if it's an open response. Okay. Now, use the same slope for parallel lines. Now, we're going to have two options. We could graph the point 2, -1, and then apply the slope down to right 3, or up to left 3 until we hit the y-axis. Now, unfortunately on purpose, I made it so that this particular line would hit the y-axis on a decimal location. So, it's not intended to be a y = mx plus b equation. It's actually intended to be point slope form. So what you'll see is the choices on the test questions will reflect which format you're supposed to use. So you're never going to know. What you're going to find out is that it just will be a decimal if you try to do it using y = mx plus b form. They'll never tell you. You just have to have both in your arsenal. And in this case, it would be best to use the point slope form. So the slope would be the same, which I'm identifying as -2/3 because I'm using the same slope. Now, the point that I have to travel through is 2, -1. So in my point slope form, that's going to give me x - 2 and y + 1. Then I'll replace m with -2/3. So that's what's going to happen here. Okay? Notice that the -1 for y, double negative makes it positive. Okay, so it's y minus y1. So y minus a -1 is y + 1. We want to make sure that we change that to plus. Okay, for this one, it's intended to be a graph one, so that's why I jumped down there. Okay, so I'm plotting B first. Okay, so B is over at -4, 2, and it was pretty quick. You didn't have a chance to look at it. The slope of the original line was 2, so we're going to apply the same slope to this new line. It's going to be parallel. So B is located. I'm going to, from there, go up to right 1. What I'm looking for is I have to continue to go up to right 1 until I reach the y-axis. Then once I reach the y-axis, I would count how high up on the y-axis it is. And it's at +10. Okay, so that on the graph, it crossed the y-axis at 10. So now it's y = 2x + 10. Okay. The next one. Now there is a way to graph lines that are in standard form. We're not going to teach it. There's just too much to do, too little time. So we're going to solve into y = mx plus b format. That will get us a slope of -1/2. And then, okay, so then that's intended to be a decimal on the y-axis. So this should be point slope form for number 3. Okay, so get the slope for this line first. So I would solve. Okay, slow down a little bit. So -x/2 is the same as saying -1/2 times x. So the slope is -1/2. The same slope, I must use -1/2 through this point. It'll be y minus -6, that's y + 6, x minus 5 in the parentheses. Okay. That's the parallel symbol, the double vertical line there. And we're plugging in. I got to slow it down a little bit. So right there, that's what it looks like with 0.5 -6. Done. All right, now on to perpendicular. All right, perpendicular, we need to use slopes that are negative reciprocals. Negative reciprocals, I don't really want to say it like this as a teacher, but you take the fraction, flip it, and change the sign. Please use the term when you're writing negative reciprocal though. Stay away from opposite reciprocal. It's going to be tempting to say opposite reciprocal. Please don't. Negative reciprocal. All right. So first you should identify the slope of this line. It's negative 2/3. Then we're going to use the upside down T symbol for perpendicular. So a perpendicular line has a slope that's 3/2. I flipped the fraction and changed the sign from negative to positive. So from there, this one could be graphed. I think I used, let me just see, I might have used point slope. Yeah, I did. I could have graphed this one though. Okay, so it was y minus -1, x minus 2. Please change that. We don't want to have double negatives. Okay, the next one should, yes, I created it so it could be graphed. So I think I will go down and graph that one. The slope of this line is 2/1. A perpendicular line should have a slope that is. So real quick on here. 2 is the same as saying 2/1. We want to have a ratio there, so we can have a reciprocal. So we flip it. So perpendicular line should have a slope that's -1/2. So this time we're going to graph, and what we're going to be looking for is when. So first I plot the -4, 2, the location. Now this is going to be a little bit tricky for students. When you plot coordinates, it's x direction first, so -4. I went 4 to the left from the origin, and then up 2. So coordinates are left or right first, up or down second. Slope, unfortunately, is the top number is up or down, and the bottom number is left or right. So you got to keep them straight. It's going to be tricky. So from B, I'm going down 1 right 2 to plot my next point, down 1 right 2 again, and continue on. I have my y-intercept at 0. Okay, so I could have stopped there. Okay, now I'll write my equation with a slope that is 0. I'm sorry, a y-intercept that is 0. You could have said -1/2 x plus 0, but I just left it on. All right, number 6. I believe, yes, we could graph this one, but I think the y-intercept will be pretty big. So I'm going to solve for the slope of -1/2 again. So that this line slope is -1/2. Perpendicular line, the slope will be 2/1. The point I'm trying to pass through is 5, -6. So again, same thing, y minus -6 equals 2 parentheses x minus 5. Please don't leave it. Double negative really isn't good. Okay, so we finished there, and that's it for parallel and perpendicular lines.